రాస్తుండే అక్కడ. Okay, so for any given transfer function, we need to draw the Bode plot. Okay, and after drawing the Bode plot, we need to find the crossover frequency. Okay, phase crossover frequency, gain margin, and phase margin. So these are 4 things we need to obtain from the Bode plot. Okay, so first of all, we need to take the sinusoidal transfer function while you are taking the g of s. Okay, normal గా మనకి g of s ఎలా ఇస్తారంటే g of n h of s. So this is going to be 20 divided by s into some s plus 3 or s plus 5, like that. Normally we have seen all the problems in this fashion. When you are going for the drawing the Bode plot, we need to write in terms of 1 plus s into t something. Okay, so 1 plus s into t2, like that we have to write. Okay, so here 1 plus s t3, okay, constant k or any particular value, okay, divided by s rs square terms. Always remember that the given transfer function must be transferred converted into in this form. Okay, so here problem is directly given in this format, but in case the problem is given like this in the g of s format, so we need to convert this into 1 plus st something. So s into, so here 3 we need to take common, so 3 into 1 plus s by 3. Okay, so here we need to take 5 common, so 5, let us take the 5 common, so this is going to be s by 5. Okay, so 5, this is going to be 20 divided by 15. 5 3s are 15, so 3 into 5, 15 here, divided by s into 1 plus s into 0.33. Okay, 1 plus 0.2 into s, because 1 by 5 is nothing but 1 by 5 is nothing but 0.2. So all the transfer functions, okay, so we need to uh, convert to this form. Okay, first thing what we have to do is this point. Okay, after that we need to take the sinusoidal transfer function by putting s is equal to j omega. So in terms of s, here we need to convert this into j omega. Okay, so this is called the sinusoidal transfer function. Okay, so the sinusoidal transfer function of g of s is obtained by replacing s by j omega in the given transfer function. So that is g of j omega is equal to 20 divided by s. So here s is there, so I directly we are writing as j omega 1 plus j, so 3 times of j omega, 1 plus 3 times of j omega here, 1 plus 4 times of j omega. Okay, so after taking this value, we need to find the corner frequencies. Okay, so corner frequencies are nothing but this values 1 by this particular value. This is a 3 or 4. Okay, so we need to write in terms of increasing order. We need to write in terms of increasing order, and therefore this value is equal to C1 is equal to 1 by 4, so 0.25 radians per second. and the second corner frequency is 43, which is equal to 0.33 radians per second. Okay, so for our problem, the corner frequency omega c1 here, if you let us take this problem, omega c1 will be equal to 3 3 and omega c2 is equal to 5. Okay, so this is a radians per second, this is also radians per second. Okay, so increasing order we need to take, so that is omega c1 and omega c2. After that, the rules here, these are the rules for the construction of Bode plots. So first one is represent the open loop transfer function in the standard time constant form. Then substitute S is equal to j omega. Then find the corner frequencies. Okay. So once you get the corner frequencies, then arrange them in the ascending order. After that, we need to consider the starting frequency of the Bode plot. The starting frequency normally it will be chosen as a 1 by 10 times of the minimum corner frequency, 1/10 of the minimum corner frequency, or normally you can also start with 0.1 radians per second, whichever is the smaller value. And then draw the Bode plot up to 10 times, up to 10 times the maximum corner frequency. So here you are taking omega c1 and you are obtaining omega c2. So you have to start with omega L, the lowest corner frequency. This will be equal to 1/10 of omega c1. Okay, and you need to end at highest corner frequency, which is a 10 times of omega c2. Okay, so these four values should be taken. Okay, so if it includes omega c1, c2, c3, and so on, so just whatever it may be, this is given in the system, but you have to start with the lowest corner frequency and you have to end with the highest corner frequencies. Then after taking these corner frequencies, then we draw the magnitude plot for each term. Each term means this is for term 1, 2, 3, 4, like that, and we can combine this plot. Okay, so you will get the magnitude plot. So the Bode plot consisting of two plots. One is the magnitude plot, and next one is the phase plot. Okay, so we need to draw the magnitude and phase plot. So after drawing the magnitude plot, then we need to draw the phase plots. Okay, so we'll see how to draw this. So the corner frequency is the frequency at which there is a change in the slope of the magnitude plot. So the magnitude plot slope will be changes at particular frequencies. Then, so for the problem is given as here g of s is equal to, our problem is given as g of s is equal to 20 divided by s into 1 plus 3s into 1 plus 4s. This was the problem. So we are converted this into g of j omega, which is equal to 20 divided by j omega into 1 plus 3 times of j omega into 1 plus 4 times of j omega. So this was the problem what we have discussed. So now whenever you are going for drawing the magnitude plot, so this should be the table you have to make it. Okay, always. So this is a fixed table. Okay, the first term includes the term, corner frequency, the slope, and the change in slope. Okay, so as a first step, we need to take up the functions here k by s or k into s terms. We need to take the first function. Okay, in our problem has given us some constant k by s. Okay, is maybe s square, okay, or s cube, like that. You may get any value, or you can also get 20 times of s or s power n. Okay, or this is a 20 divided by s power n. So whenever you are seeing this type of problems, either you see this type or this type, so the first step is to take the functions will be k by s power n or k into s power n. Okay. So for the first term, you have to write. The term one is nothing but k by s power n term or k into s power n term. So for our problem, so we has given as 20 by j omega. Therefore, we are taking it to 20 divided by j omega. And for these functions, there is no corner frequency. There is no corner frequency for these functions. Remember this. Okay. Next one, the slope. So as this is a 1 by s, therefore you are having a slope of minus 20. Okay. If it is going to be s power n, then the slope will be minus 20 times of n. Just remember this. Okay. So I will use another pen here. If this is a s power of n, only there is some constant k into s power of n is given to you. So this value is going to be plus 20 times of n. You have to consider these values. Okay. అర్థమైందండి ఇక్కడ ఏమైనా డౌట్ ఉందా? So k by s power n ఇచ్చారనుకోండి, this is going to be minus into n, the slope. If k into s power n is there, the slope is plus 20 into n. So the first table we have to draw. For the first row, we have to consider these values. Okay, then there is no change in slope. There is no change in the slope. So after that, the next term we have to take is the lowest corner frequency. Omega C1 we need to take. The lowest corner frequency what we have seen is 1 by 4. So you need to take that particular term. So k, this is a 20 divided by j omega. Okay, 1 plus 3 j omega into 1 plus j 4 omega. So this term, so we finished the first term in the last case. So then you need to consider this term. So the second term should be represented here. So after taking this, what is the corner frequency for this? This is a 1 by 4. So whatever may be the value here, this is taken as a 1 by 5. So it is going to be 0.25 is the corner frequency. Then just you remember here again 1 by 1 plus s into t or t power n. This is the denominator value. Okay, so this is in denominator value. Therefore, your slope is going to be minus. This slope is minus. ఒకవేళ కనుక మీకు ఈ టర్మ్ న్యూమరేటర్ టర్మ్ అనుకోండి 1 plus some s into t to power n. Okay, then this should be considered as a plus 20. Okay, if the function this term is in the numerator, you have to consider the slope as plus 20. If this first order term in the denominator, then you have to consider this as a minus 20. Okay, if it is power of n is there, then it should be multiplied with n. This should be multiplied with n. Okay, so here in this above case also, this is a plus 20 times of n. Okay, so this is the numerator term, the term in the numerator of your transfer function. This is the denominator term. So ఇక్కడ మనకి కనిపిస్తుంది మనం తీసుకున్న 1 by కాబట్టి this is going to be minus 20. Then what is the change in slope here? The change in slope is here minus 20 is there. In previous case it was minus 20. Now you are having a minus 20 because n is equal to 1. So this will be minus 20 only. Then this minus 20 you have to represent here. So now what is the slope? Minus 20 minus 20. This is going to be the slope of minus 40. Okay. Then, so minus 40 is there. The next you have to consider is the remaining term 1 by 1 plus 3 omega, and the corner frequency is 0.33. And again, this is a denominator term and the power of 1. So the slope is minus 20. So this slope, original slope is 40 minus 40. Then this slope we have to add up, minus 20. So your slope is going to be minus 60. This is the change in slope. Okay. After completing this table, ఇంకొకటి గుర్తుపెట్టుకోండి, మీరు ఎప్పుడైనా ఫస్ట్ చూస్ చేసుకోవాల్సింది ks power n or k by s power n term. The first term, always the first term will be like this. Okay, and the second terms, always you have to take the first order factors. First order factors we need to consider. These first order factors will be 1 plus s into t power n. Okay, this is in the numerator. Okay, 1 by 1 plus st power n, this is in the denominator. Okay, and therefore this will contribute plus 20 into n, and this will contribute minus 20 into n. Okay, after that we need to take the second order factors. Second order factor. Okay, so second order factor ఎలా ఉంటుంది? So 1 by s square plus 2 zeta omega n into s plus omega n square. Okay, so this will contribute plus 40. The second order term always sorry, here this is in a denominator, therefore it will contribute minus 40. Okay, if it is n is there, then this should be considered as minus 40 into n. Okay, then if this is a numerator factor, s square plus 2 zeta omega n into s plus omega n square, this is in the numerator, then this will be 40 times of n, 40 into n. ఇది మనకి స్లోప్ ఇక్కడ తీసుకోవాల్సిన వాల్యూ. Okay, so after that this first order terms are finished, then we need to consider the second order term. In our problem, the second order problem is not given, therefore we are not choosing this one. Okay, so when you come to the corner frequency omega n, this is a natural frequency of the second order system, is nothing but your corner frequency. Okay, so మీకు ఇచ్చిన సిస్టమ్ లో నుంచి ఈ omega n calculate చేయండి. I told you how to find the things here. This is s square plus 5s plus 25 ఉందనుకోండి, omega n square is equal to 25, so omega n is equal to 5. Okay, so ఇలా మీకు ఇచ్చిన సిస్టమ్ లో నుంచి న్యాచురల్ ఫ్రీక్వెన్సీ చూస్ చేసుకోవాలి, దట్ షుడ్ బి రిప్రజెంటెడ్ ఇన్ ద లాస్ట్. ఓకేనా, ఇంకెక్కడన్నా డౌట్స్ ఉన్నాయండి దీంట్లో? Once again I will tell you how to fill this table. The first thing what we have to choose is k s power n or k by s power n. K s power n will contribute plus 20 times of n, k by s will contribute minus 20 times of n. Once you finish this, then the second one is the first order factor. Okay, first order factor is in the numerator or denominator. The numerator is plus 20 into n, denominator is minus 20 n. Okay, after that we need to take the second order factor. Okay, so second order factor will be represented as 1 by s square plus 1 by s square. So corner frequencies make it 1 by 4. Okay, ఇక్కడ ఏదైతే వాల్యూ ఉంటుందో this value will be taken as a corner frequency. And for the second order system, always the natural frequency is the corner frequency for the second order term. Okay, so normal ga meeku ఇలాంటి ఫంక్షన్స్ ఇస్తారు. సో s square plus 5s plus 25, సో దీంట్లో నుంచి మనం omega n square is equal to this 25 ఇది తీసుకొని ఇక్కడ సబ్స్టిట్యూట్ చేయాలి. ఓకే, తర్వాత ఇక్కడ మళ్ళీ టేబుల్ ఫిల్ చేయాలి. ఓకేనా, సో ఈ టేబుల్ ఇప్పుడు మన ఈ ప్రాబ్లం కి ఈ టేబుల్ ఇక్కడితో ఫినిష్ అయింది. సో -40 అండ్ -60. తర్వాత ఏ ప్రాబ్లం అయినా తీసుకోండి, వన్స్ యూ ఫినిష్ దిస్ టేబుల్, then the next step is choosing a lower corner frequency and a higher corner frequency. Lower corner frequency, we should be less than the 1/10th of your lowest corner frequency. So that means here 0.25 your lowest corner frequency. So 1/10th of that, omega L is equal to 1/10 times of omega C1 we are choosing. So this is 0.025. Okay. తర్వాత highest corner frequency మనం choose చేసుకోవాలి. Highest corner frequency is obtained with the 10 times. So this is equal to 10 times of omega C2. Omega C2 is 0.33. Therefore, we are choosing this as a 3.3. Okay. ఇది టేబుల్ ఫిల్ చేసుకోవడం ఫస్ట్. Okay, so we are ready with omega L. Okay, omega L is equal to 0.025. Omega C1 is equal to 0.25 and omega C2 is equal to 0.33 and omega H is equal to 3.3. సో మనకి ఈ పర్టికులర్ ఫ్రీక్వెన్సీస్ దగ్గర మ్యాగ్నెట్యూడ్స్ కావాలి. సో టు డ్రా ద బోర్డే ప్లాట్, వీ నో ఫ్రీక్వెన్సీ, ఎక్స్ యాక్సిస్ పాయింట్స్ మనకి తెలిసాయి. దాని తర్వాత మనకు కావాల్సింది ఏంటంటే మ్యాగ్నెట్యూడ్స్ కావాలి. ఓకే, సో ఫర్ ఫైండింగ్ ద మ్యాగ్నెట్యూడ్, ఫర్ ఫస్ట్ కేస్ at omega L, we need to consider our transfer function. Okay, A will be equal to always 20 times. So our transfer function is 20 divided by S into 1 plus J 3 omega 1 plus J 4 omega. So this is our transfer function. So the first term will be contributed by only this one. So 20 by S. So దాని కోసం ఏం చేస్తారంటే this value will be always equal to 20 divided by this is slope. Okay, so 20 log of this 20 by S. Normal this will be K by S. The formula is K by S here. Okay, so K value is 20 by S. So S value enta తీసుకున్నాం మనం. S అంటే this is J omega, not S. This is J omega. So 1 by omega, K by omega we have to take. This is a K by omega. So omega is equal to 0.025 at omega L. As this is omega L, this value is going to be omega L. And therefore this is a 20 log of 20. సో ఇచ్చిన ట్రాన్స్ఫర్ ఫంక్షన్ లో ఏ టర్మ్ ఇక్కడ ఉంటుందో ఆ టర్మ్ ఇక్కడ తీసుకోవాలి. ఒకవేళ మీకు K ఇంటూ ఒమేగా ఉందనుకోండి, then directly you have to take this K into omega. Okay, so this is a 20 log of this K by omega. This will give you 58.06. Okay, then after that at A we need to find omega C1. That is, A is nothing but slope from omega L to omega C1. Slope from omega L to omega C1 into log of omega C1 by omega L. ఈ ఫార్ములాస్ డైరెక్ట్ గా గుర్తుపెట్టుకోండి. ఒక ఫార్ములా వస్తే మిగతా ఇవన్నీ వచ్చినట్టే. సో ద స్లోప్ ఫ్రమ్ omega L to this omega L to this omega C1 into log of omega C1 divided by omega L, omega C1 divided by omega L, plus gain A at omega L, gain A at omega L. Okay, so that is, what is the change in slope from omega 1 to omega L? Then this transfer function, this is a omega L to L, this is a -20. Okay, so the slope is -20. Okay, then log of omega C1. So omega C1 is 0.25. Log of 0.25 divided by 0.25. 0.025 plus this gain, the gain at this value. Okay, 58.06. So you're getting the value of 38.06. Okay, next we'll come to C2. Okay, C2 is nothing but again the slope from omega C1 to C2. The slope from omega C1 to C2, then log of omega C2 by omega C1. Okay, so this value log of omega C2 by omega C1 plus gain at omega C1. So this is actual ga manaki formula y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. This was the formula normally we use, okay, for finding the straight line equation. So the same thing we are using here with the values of logarithms. So the formula is same now. Okay, the slope is from omega c1 to c2 log of omega c2 by c1 plus gain at omega c1. So just you substitute these values, the change in slope from omega to c2. C1 to C2 ఎక్కడ వచ్చిందండి ఇది this, okay, minus 40. Okay, so minus 40, the slope, change in slope is minus 40 log omega c1 is 0.33 divided by 0.25 plus 38, this one. Okay, so you get the value of 33 decibels. Okay, then WH, that is highest frequency. So again the slope from again omega c1 to c2 h omega c2 to h wh and log of omega h by omega c2 omega c h by omega c2 plus gain at omega c2. So you will get this magnitudes, you will get all these magnitudes. ఓకే, మీకు ఇంకా ఎన్ని మధ్యలో ఒమేగా C2 C3 ఎలా ఉన్నాయండి, జస్ట్ దిస్ ఫార్ములాస్ ఓన్లీ. ఓకే, దీని తర్వాత మనకి ఇక్కడ మ్యాగ్నిట్యూడ్ వచ్చిందండి, మ్యాగ్నిట్యూడ్ 58, 38, 33 అండ్ 27. ఓకే, దెన్ we need to find the phase plot. Okay, so to find the phase plot we need to write the phase angle. Phi is equal to, so this value by s is there, so this will contribute minus 90 because 0 minus j omega plus j omega. So t is equal to tan inverse of omega by 0. So this is nothing but infinite. Tan inverse of infinity is 90 degrees, and then minus this one, tan inverse of 3 omega by 1, tan inverse of 3 omega divided by 1. Okay, and here this is the tan inverse of omega 4 omega by 1. Okay, so you are having an equation in terms of phase angle phi. Phi is equal to, now you substitute different values. Okay, so 0, 0.25, 0.3, 0.3, like that, you can increase up to infinite. Okay, so you will get these phase angles. Okay, so once you get these phase angles, now you can draw the polar. Okay, so first one at 0.025 we are getting it as a 58. Okay, then here at 0.25 38 around, and then 0.33 దగ్గర మనకి 33 వచ్చింది. Okay, next 3.3 దగ్గర minus 27 వచ్చింది. So we have to locate these points first. Always we have to locate these points. Okay, పాయింట్ తో లోడ్ చేయండి, ఇలా పాయింట్. తర్వాత మీరు స్కేల్ తీసుకొని ఈ పాయింట్స్ ని జాయిన్ చేయాలి, ఫస్ట్ 2 పాయింట్స్ ని జాయిన్ చేయాలి. డోంట్ డ్రా దిస్ విత్ ద హ్యాండ్. ఓకే, ఒకవేళ మీకు పెన్సిల్ స్కేల్ లేకపోయినా జస్ట్ పెన్ అయినా యూజ్ చేయండి. ఫస్ట్ ఈ 2 పాయింట్స్ జాయిన్ చేయాలి, తర్వాత నెక్స్ట్ 2 పాయింట్స్ జాయిన్ చేయాలి, తర్వాత మిగతా 2 పాయింట్స్. So here you have to write that the slope is minus 20 dB per decade. ఓకే, తర్వాత ఇక్కడ స్లోప్ వచ్చేసి minus 40 dB per decade. తర్వాత లాస్ట్ స్లోప్ వచ్చేసి minus 60 dB per decade. ఇలా స్లోప్ రాయాలి. సో ఇక్కడ వచ్చిన తర్వాత నెక్స్ట్ ఫేజర్, మళ్ళీ మనకి ఫేజర్ ప్లాట్ కావాలి. సో ఈ రైట్ సైడ్ తీసుకోండి యాంగిల్స్, మీకు ఇక్కడ కంటే ఇంకా రైట్ సైడ్ 30, 40, 30, 60, 90 ఎట్లా తీసుకోండి. రైట్ సైడ్ మీరు యాంగిల్స్ తీసుకొని just according to that you draw the phase angle with the same values. So x axis లో మీకు అయితే ఏ వాల్యూస్ అయితే తీసుకున్నారో అవే. ఓకే, మీరు ఇక్కడ ఇది నార్మల్ గ్రాఫ్ కాదు, జస్ట్ యూ సీ దట్ దిస్ ఇస్ ఏ లాగరిథమిక్ గ్రాఫ్. సో ఫస్ట్ మీరు తీసుకునేది 0.01. ఓకే, ఇట్ ఈస్ 0.01 అయినప్పుడు ఇది 0.1 అవుతుంది, ఇక్కడ 1 అవుతుంది, దిస్ విల్ బికమ్ 10. ఓకే, సో మీకు అందరికి తెలుసు ఇది, జస్ట్ ఇలా మీరు పెట్టేసుకోండి. సేమ్ ఆ ఫ్రీక్వెన్సీస్ కి మీరు ఫేస్ ప్లాట్ డ్రా చేయండి. ఓకేనా, ఈ ఫేస్ ప్లాట్ వచ్చిన తర్వాత మనకు కావాల్సింది ఏంటంటే ఫేస్ మార్జిన్, గెయిన్ మార్జిన్ కావాలి. we need to find phase margin and gain margin, but before that we need to find gain crossover frequency and phase crossover frequency. Okay, so gain crossover frequency ante this one, sorry. So omega gc kavali, omega pc, this is a gain crossover frequency, this is a phase crossover frequency. So gain crossover frequency is nothing but where the gain is 0 here, decibel magnitude is 0, that particular frequency is known as the gain crossover frequency. Okay, and phase crossover frequency is where the phase plot is crossing, minus 180 degrees line. So here this is a minus 150 and minus 200. So in between this is your minus 180 degrees line. So ekkadaithe minus 180 degrees line ni cross avutundo a particular frequency ni, this frequency is called as omega pc. Okay, so here this value is 0.3 radians per second, just you observe here. Okay, this is the 0.3. okay, ikkada vastundi meeku. Next ekkadaithe meeku zero magnitude, this magnitude plot is crossing the 0 decibels here, and this particular frequency is known as the gain crossover frequency. Okay, and after that from the gain crossover frequency we need to draw the line, and from minus 180 to this particular point. Okay, so this is going to be the phase margin. Okay, 180 degrees and this particular value. So this phase margin gamma is given as gamma is equal to 180 degrees plus 5 gc. 180 degrees plus 5 gc. 5 gc is nothing but this particular angle. Okay, so here this dotted line where this is crossing your particular point. So మనకి ఎక్కడైతే గెయిన్ మార్జిన్ 0 వచ్చిందో అక్కడ నుంచి మనం డాటెడ్ లైన్ డ్రా చేస్తే ఫేజ్ వాల్యూ వస్తుంది మనకి. Okay, so that particular phase value is nothing but 5 gc, and this 5 gc is equal to minus 240. So phase margin is equal to 180 degrees minus 240. So this is going to be minus 60 degrees. Minus 60 degrees is the phase margin. అలాగే గెయిన్ మార్జిన్ కావాలి అన్నప్పుడు మనం ఏం చేయాలంటే ఫేజ్ దగ్గరికి రావాలి. ఓకే, ఎక్కడైతే ఫేజ్ క్రాస్ ఓవర్ ఫ్రీక్వెన్సీ ఒమేగా సి ఉందో అక్కడ నుంచి మీరు లైన్ డ్రా చేయండి. ఓకే, సో ఈ పైనకి పర్టికులర్ వాల్యూ దగ్గరికి ఈ 0 నుంచి పర్టికులర్ వాల్యూ, దిస్ ఇస్ అ జిఎం. ఇక్కడ మీకు గ్రీన్ లైన్ ఉంది చూడండి, ఇక్కడ రెడ్ చేస్తున్నాను. ఓకే, సో దిస్ లైన్, ఓకే, దిస్ ఇస్ నథింగ్ బట్ యువర్ gain crossover frequency, gain margin. Okay, so that gain margin is equal to 32 decibels. Okay, so minus 32 decibels. So here, సో 20 log of g of j omega g. సో ఇక్కడ మీకు ఈ వాల్యూ తెలుస్తుంది. ఇక్కడ 32 వచ్చింది కదండి. దిస్ ఈస్ a -32 you have to take. Okay, that is the gain margin. Okay, so once you get these values, here we can conclude that omega gc is nothing which the dB magnitude is 0. That particular frequency is known as 1.1 radians per second, and the phase crossover frequency is 0.3 radians per second, where it crosses the minus 180 degrees line. Here this magnitude is 0. So those values are called as gain crossover frequency and phase crossover frequencies. Then those values, if you substitute in a magnitude equation also, directly you will get these values. So there is a gain margin and phase margin. Okay, so for this system, gain margin and phase margin both are negative, and therefore the system is unstable. Okay, so this should be positive for the system to be stable. So by using the gain crossover frequency and phase crossover frequency also, you can directly find out. Okay, so for the stable systems, omega gc must be less than omega pc. Our omega gc, our problem omega gc, we got it as 1.1 radians per second, and omega pc we are getting it as a, you know, omega gc is 1.1 and omega pc is 0.3. Okay, and here the magnitude will be less than 1 here, and the gain margin should be positive. Okay, so always omega gc should be less than omega pc, but here our problem, we obtained that omega gc is greater than omega pc, therefore our system is unstable from first case. Okay, and the second case also, your omega gc gain margin must be equal to positive. Okay, so positive unte the system is stable, but our system we are getting it as a negative. So in both the cases also, you can conclude that the system is unstable. Okay, so for marginally stable systems, omega gc is equal to omega pc. Both are equal, and the gain margin should be equal to 0. Okay, and for unstable systems, we obtain that omega gc is greater than omega pc, and the magnitude is greater than 1. Gain margin is negative. So this is the way of obtaining the stability from the Bode diagrams. Okay, so ఇది ప్రొసీజర్, ఇదే సేమ్ ప్రొసీజర్ మీకు ఏ ప్రాబ్లం ఇచ్చినా ఫాలో అవ్వండి టు ఫైండ్ ద Bode diagram. Okay, is there any doubts on this? So next నేను స్టేట్ స్పేస్ అనాలిసిస్ కి వెళ్తాను. జస్ట్ ఐ విల్ గివ్ యూ ద బ్రీఫ్ ఇంట్రడక్షన్. Okay, this is a general state space representation of the system, which is given as a state equation and output equation. Okay, the state equation is equal to x dot is equal to ax of t plus bu of t. Okay, so this is a state variable and this is the input. This is a state variable and input. A is called as a state matrix or system matrix. B is known as the input matrix. C is known as output matrix. D is known as the feedback matrix. Okay, so for any given system, there are number of energy storage elements are equal to the number of state variables. The number of energy storage elements, RLC undanukondi, LC, energy storage elements LC. So the number of energy storage elements equal number of state variables are equal to the number of energy storage elements. Okay, so this is a general representation of a state space equations. So x of t is equal to x1, x2, and so on xn. U of t is equal to the number of inputs u1, u2, and so ur. And y of t is the output equation. Y of t is nothing but the output equation. There are p number of outputs, and these are the initial conditions. X naught is nothing but the initial condition. Okay, so here A is given as A n by n matrix, B is n by r matrix, P by n is a C, and P by r is for the. So this is a general block diagram representation of a state model. Okay, so here this will be representing a feedback is representing here A, the input with B. Okay, so just you are going to get your x dot is equal to now ax plus bu, and y is equal to cx plus du. Okay, so here u is coming here, so output is equal to c into x, okay, plus into u. So this one you are getting. Okay, so we have to close from I. So I will take a example here how to represent the state model. Okay, normally this is a mechanical system. This is given by the mass m. Okay, you are applying the force, and this is mass is connected with the dash part and the k spring. Okay, so for this is your equation here. So normally m into, we know that this is a d square x by dt square plus b into dx by dt plus c or k, constant k, is equal to your f of t. Okay, k into x, normally k into x. So ఇక్కడ x బదులు ఏమి ఇచ్చారంటే y ఇచ్చారు కాబట్టి just we are taking it as a d square. So you are getting it as m into y double dash plus y dash plus k into y is equal to f of t. This is the balance, energy balance equation for the given mechanical system. Okay, so for this system we need to draw a state variable, state space model. Okay, so let us assume that there are two state variables. Okay, because two energy storage elements are there, two state variables are available, which is nothing but x1 and x2. Okay, so here x1 we are assuming it as a y, that is your output or displacement y. Okay, and x2 is equal to y dash. Okay, we are assuming this as a two state variables. X1 is equal to y and x2 is equal to y dash. Okay, then what is x1 dash? X1 dash is equal to y dash. Normally x1 we assumed it as a y, and therefore this implies that x1 dash is equal to y dash. But y dash is equal to what we assumed here again. This is equal to x2. So this is your first equation. And then x2 dash. So మీరు తీసుకున్న రెండు స్టేట్ వేరియబుల్స్ ని డిఫరెంట్ చేయాలండి, ఏం లేదు. x1 x2 ఉన్నాయి కదా, వీటిని డిఫరెన్షియేట్ చేయాలి. Okay, so x2 dash is equal to what now? Y double dash. Y double dash. But from this equation, from the first equation, y double dash is equal to just f of t by m, okay, minus b by m into y dash plus k by b into k by m into y. Okay, so this equation. So f of t by m, f of t by m, okay, then minus b by m, y dash ni manam emantam x2, because y dash is equal to x2, and y ni x1 is nothing but x1, so minus k by m into x1. So this is going to be your state space model. Okay, so x1 dash, what we are assumed is x2, and x2 dash is equal to y double dash, which is equal to minus k by m into x1 minus b by m into x2 plus 1 by m into f of t. So దీన్ని మనం మ్యాథమెటికల్ మోడల్లో రాయాలి. Okay, so x1 dash, x2 dash. This is the state vector x1 dash, x2 dash. So x1 dash is equal to what? x1 plus 0 times of x1. So 0 x1 plus 1 time of x2. Okay, and input is not there. So again this is 0. Okay, 0 times of f of t. Tarvata minus k by m minus b by m x2. Tarvata 1 by m f of t. So this is your state space model. Alage output equations. The state space model includes the state equation and also the output equation. Okay, so output equation what we are shown, x1 is equal to y. So y is equal to x1 only. Y is equal to x1 only. That's why 1 0 x1, and there is no input for this f of t, 0 into f of t. So d is equal to 0. Okay, so this is your state equation and this is your output equation. So then మనం బ్లాక్ డయాగ్రామ్ లో ఇలా రిప్రజెంట్ చేయాలి. ఓకే, సో అలాగే ఎలక్ట్రికల్ సిస్టమ్ తీసుకుంటే ఫర్ a series RLC circuit we need to draw the state space model. మీకు ఒక 5-6 మార్క్స్ కి ఇలా ఏ బిట్ బి బిట్ లో వచ్చింది అనుకోండి, జస్ట్ యూ కెన్ సాల్వ్ దిస్ వన్. ఓకే, RLC, so E I of t is equal to R into I of t plus L into di of t by dt plus 1 by C into integral of I of t into dt. Okay, so here what we are assuming it is x1 dash is equal to I of t. The current ne first state variable anukunnam and integration of I of t ni second state variable anukunnam. So మనకి ఇక్కడ I of t ఇప్పుడు నెక్స్ట్ ఏం కావాలి మనకి, ఇక్కడ నుంచి x1 dash of t and ఇక్కడ నుంచి x2 dash of t. మనం అల్టిమేట్ గా కనుక్కోవాల్సింది ఇవి రెండు, దిస్ వన్. ఓకే, సో x1 dash of t is equal to I of t or d by dt of t, or d by dt of I of t, x1 dash of t అంటే. సో ఈ ఈక్వేషన్ లో నుంచి దీన్ని మనం డైరెక్ట్ x2 అనుకోండి. This will be now assumed as x2. Okay. And this is, we have to write the equation for this. So first equation మీకు వస్తుంది. ఓకేనా, దాని తర్వాత ఇక్కడ x2 తీసుకుంటే మళ్ళీ మీకు సెకండ్ ఈక్వేషన్ వస్తుంది. సో ఈ మోడల్లో మీరు స్టేట్ ఈక్వేషన్ రాసుకోవచ్చు. లేదంటే just if you assume the state equation is current passing through the inductor is one state equation and voltage across the capacitor is another state element. Okay, so this is state variable 1 is current passing through the inductor and the second state variable is voltage across the capacitor. By using these two methods also you can convert to the state model. Okay, so the values may be changes, your response is going to be the same. Okay, but this are two different ways of representing your RLC series circuit by choosing the different state variables. Okay, alage ఇక్కడ ఇచ్చిన సిస్టమ్ మీరు టూ ఈక్వేషన్స్ రాసేసి ఈ ఈక్వేషన్స్ లో నుంచి కూడా then you can convert it into the state space model. This is one type of problem. Okay, so this is another type, it is very important now. Okay, so the system is given to you. Okay, so 24, this is the input is R of s, output is C of s, so s cube plus 24 divided by s cube plus 9s square plus 26 into s plus 24. Okay, so this is a C of s by R of s is equal to 24 divided by s cube plus 9s square plus 26s plus 24. Okay, I'll write take this point to here and take this point to here. Okay, so this is s cube times of C of s plus 9 into s square times of C of s plus 26s times of C of s plus 24 C of S is equal to 24 times of RS. Okay, so S cube means there is a differentiation 3 times. So this is going to be C dot dot plus 9 times of C dot dot because it is a square term plus 26 C1 dot plus 24 C. This is equal to 24 times of R. This is the equation what we are obtaining here. Okay, so ఒకవేళ కనుక మీకు టేబుల్ ఇస్తే we need to convert this to this equation. అదర్వైజ్ డైరెక్ట్ గా మీకు ఇచ్చిన అసైన్మెంట్ లో చూడండి ఇదే డైరెక్ట్ గా ఇచ్చేసారు. సో దీనికి మనం స్టేట్ ఈక్వేషన్ డ్రా చేయాలి, స్టేట్ స్పేస్ రిప్రజెంటేషన్ డ్రా చేయాలి. ఓకే, సో ఫర్ దట్ వాట్ విల్ అజ్యూమ్ హియర్ ఇస్ మీకు 3 ఉన్నాయి కదా, this differentiation is with respect to 3, so that means your system is a third order system. Therefore you will have 3 state variables x1, x2, x3. Okay, the number of state variables are equal to the order of the system. Okay, so first of all what we assume is x1, x2, x3 మనకు తెలిసిపోయింది ఆర్డర్ ఉంది కాబట్టి 3 స్టేట్ ఈక్వేషన్స్ ఉంటాయని. తర్వాత ఏం చేయాలి మనం, x1 is equal to c. ఒకవేళ ఇక్కడ మీకు y ఇచ్చారనుకోండి, y ట్రిపుల్ డాష్ ఇస్తే జస్ట్ యూ టేక్ x1 is equal to y. ఓకే, సో తర్వాత x2 is equal to c dot, x3 is equal to c double dot. ఓకే, ఇవి మనకి స్టేట్ వేరియబుల్స్. we are assuming that these are the assumed values. assume state variables as x1, x2, x3. తర్వాత ఏం చేయాలి, మనం వీటిని డిఫరెన్షియేట్ చేయాలి. జస్ట్ యూ డిఫరెన్షియేట్ x1 dash. x1 dash is equal to what? This is a c dot. x1 dash is equal to c dot, but we are assuming that c dot is equal to x2. So x1 dot is equal to x2, and then x2 dot is equal to x3 because x3 is equal to c double dash. Then x3 dot is equal to c triple dash. C triple dash this here, x3 dot is equal to c triple dash. Okay, so this implies that this your c triple dash is equal to what from this equation? This is a 24c. So c is nothing but x1. Okay, c dash is nothing but x2, and c double dash is x3. So these equations can be represented here. Okay, and your output equation y, output is nothing but your c. Okay, from your transfer function the output is nothing but c. Therefore y is equal to c times of x1. Sorry, c is equal to x1. Okay, so only you will get the transfer function as like this 0 1 0. So here the x1 దగ్గర ఏముంది మనకి x1 dash, x2 dash and x3 dash. So this is equal to x1, x2, x3 plus r. Okay, so x1 dash దగ్గర ఏముంది only x2 నే ఉంది. So x1 is not there, x2 is 1, x3 is 0. Okay, and the input is also not there, so this is 0. Next x2 దగ్గర ఏముంది only x1 is 0, x2 is 0, x3 is 1. Okay, and your input also 0. ఇక్కడ చూడండి x3 దగ్గర x1 term is -24, -26, -9, and this input is also present here. This is 24. Okay, so this is the state equation, and your output equation is y is equal to 1 0 0. Input x1, x2, x3. Okay, so this is your output equation and this is your state equation. Okay, so in this way you have to write it. Okay, then after that you can draw the Bode. Okay, 0 1 0 0 0 1 -24 -26 -. ఓకే, మీకు ఎలాంటి ప్రాబ్లం ఇచ్చినా కూడా దిస్ ఇస్ ద మెథడ్. ఓకే, మీకు ఒకవేళ ఇస్తే మీకు అరౌండ్ 14 మార్క్స్కి ఇలా వచ్చినా కూడా ఏం కాదు. ఓకే, దెన్ యూ కెన్ డూ దిస్ ప్రాబ్లం. ఓకేనా? తర్వాత స్టేట్ స్పేస్ రిప్రజెంటేషన్ ఆఫ్ ట్రాన్స్ఫర్ ఫంక్షన్స్. సో ఈ ట్రాన్స్ఫర్ ఫంక్షన్స్ ఇదంతా మీకు ఇక లైట్ తీసుకోండి. ఇప్పుడు కావాలంటే ఇది షేర్ చేస్తే చెక్ చేసుకోండి. ఓకే, ఇదొకటి ఇంపార్టెంట్, స్టేట్ ట్రాన్సిషన్ మ్యాట్రిక్స్. State transition matrix, then the properties of the state transition matrix. ఇది చూసుకోండి, దీనిపైన ప్రాబ్లం. ఓకే, how to find the state transition matrix is one thing. ఇది ఇప్పుడు చాలా టైం పడుతుంది అది. ఓకే, సో controllability and observability, this is very very important. Okay, controllability and observability. So every point, every element with constant to the input is connected, then that system is controllable. Okay, so this is a system. Okay, and the definition of the controllability is this screenshot తీసుకోండి. ఓకే, లేకంటే నేను లింక్ ఇస్తాను, అప్పుడైనా చూసుకోండి. ఓకే, definition of the controllability. ఓకే, and the controllability matrix. మీరు ఇది కంపల్సరీ చూసుకోండి. ఒకవేళ కనుక మ్యాక్సిమం వీలుంటే మీకు ఏదైనా క్వశ్చన్ దీనిపైన వస్తుంది. ఓకేనా? Just controllability plant, this is a plant. Okay, definition of a controllability. Okay, and the controllability matrix is b b a square b and so on, a minus into b. Okay, so if this is the rank is same, the order of the system, then the system is said to be controllable. Okay, so let us take this system here. X1 dot is equal to here. This is a state equation. A matrix A is given to you, matrix B is given to you, matrix A is given, B is given, C is given. Okay, so controllability matrix is BAB. Okay, ikkada order of the system is 2 only, therefore you will get only BAB. If the order of the system is 3, you are going to get BAB and A square B. Okay, so you can make a n minus 1. Okay, up to this will be b a b and so on, a n minus 1 into b. So ఇక్కడ ఆర్డర్ ఎంత 2 కాబట్టి minus 1 is 1. So ఇక్కడ వరకు ఫినిష్ అవుతుంది. If this is the third order system, 3 minus 1, so that is a square b. Okay, so first of all, b as is b, we know 0 and 1. AB is nothing but this one. We have to calculate multiplication of matrix A and matrix B. So 0 1 minus 6 and minus 5, minus 6 minus 5, B matrix 0 1. So just we multiply this, you are going to get 1 and minus 5. Okay, and therefore this matrix is 0 1. So B is 0 1, B is 0 1, B is 1 minus 5. Okay, so here the determinant of this is minus 1. Okay, it is not equal to 0, and therefore the system is controllable. So like this, we need to find out the controllability and observability. Okay, so next observability. Here also, this is also a controllability matrix. The x2 is not connected here with the input. X2, this x2 is not connected with the input. Then this is directly say that uncontrollable. Ledanti matrix ila esena chudandi, B and AB. Okay, just you find the rank of the matrix. Okay, ఇది proof. తర్వాత observability. Okay, so here x1 is observable, but x2 is not connected with your output. For output, this x2 is not connected, that's why it is not observable. X1 is directly connected with the output, so it is observable. Okay, so this is the definition for observability. Okay, and the function is like C. So C, CA, CA square, and so on, CA power n minus 1. Just you remember this. Okay, so mathematics is the director, ABC is the. Okay, just we need to find out the matrix C, CA. Determinant కనుక్కోండి. ఒక రియల్ వస్తే జీరో వస్తే నాట్ కన్వర్టబుల్ అబ్జర్వబుల్. ఓకే, ఇది మీకు ప్రూఫ్. Okay, so here rank is equal to, it is order of the system. The rank of the system is equal to the order of the system. Therefore, these two are controllable and observable. Okay, so this is a plant is given, A, B, C is given to you. Then controllability matrix is B and AB. Okay, AB is nothing but 0, 1. So 0 plus 1, 1. Okay, 1 into 0, 0 into 0. So this is going to be 0. B is 0, 1. So this is your controllability matrix. Okay, so this is the rank is 2. Okay, alage manaki observability matrix ఏమవుతుంది, C రాయాలి first. Okay, this is C. C is nothing but 0, 1. Okay, తర్వాత C multiplied with A. Okay, so C multiplied with A అంటే 0, 1, 1, 0. Okay, so 0 into 0, 1 plus 1, 1. This is equal to 1, and 0 into 0, 1 into 0. This is 0. So 1, 0. Sorry, ఇలా రాయాలి కదా. So here this is 1 into 0, 1, 0, 0. So 0, 1, 1, 0. Okay, so this is also having same rank. So the both these are controllable and observable. Okay, just a mirror. You can నేర్చుకోండి controllability and observability duality. Okay, so for this system, this is your state space representation. Okay, the controllability matrix, and this is your observability matrix. Okay, so rank is n. The rank of V is not, this is 1, so it is not equal to n. Therefore, it is uncontrollable. Okay, so here also second system here 1. Okay, so we need to find B and AB, C, CA. Okay, ఒకవేళ మీకు థర్డ్ ఆర్డర్ సిస్టమ్స్ ఇస్తే మీరు ఎలా చేయాలి జస్ట్ నేర్చుకోండి, ఇది ఒక ప్రాబ్లం నేర్చుకోండి. ఓకే, సో ఐఎమ్ స్టాపింగ్ హియర్. డౌట్ ఉన్నా కాల్ చేయండి. ఓకే, ఎనీ డౌట్స్? మీరు లాస్ట్ యూనిట్లోనైతే లీడ్ ల్యాగ్ కాంపెన్సేటర్స్ కంపల్సరీ చూసుకోండి. మాక్సిమం థియరీ క్వశ్చన్ అది ఇవ్వడానికి ట్రై చేస్తాను. ఓకే, ల్యాగ్, లీడ్, లీడ్ ల్యాగ్. ఓకే, అదొక క్వశ్చన్. కంట్రోలబిలిటీ, అబ్జర్వబిలిటీ ఒకటి. తర్వాత బోర్డ్ ప్లాట్, రూట్ లోకస్, స్ట్రైక్, ఆర్హెచ్ క్రైటీరియా. అట్లీస్ట్ మీరు ప్రొసీజర్ ప్రాబ్లం అంతా చేయకపోయినా ప్రొసీజర్ అయినా రాసుకోండి. ఓకేనా? నెక్స్ట్ దాంట్లో సెకండ్ ఆర్డర్ సిస్టంలో రెస్పాన్స్ ఆఫ్ సెకండ్ ఆర్డర్ సిస్టమ్ ఫర్ స్టెప్ ఇన్పుట్ చూసుకోండి, టైమ్ డొమైన్ స్పెసిఫికేషన్స్ చూసుకోండి. ఓకే, అదొక క్వశ్చన్ వస్తుంది. తర్వాత స్టడీ స్టేట్ ఎర్రర్స్, దానిపైన ప్రాబ్లం. ఓకే, సో దిస్ ఈస్ ద సిలబస్ ఫర్ యువర్ ఎగ్జామ్. ఇంపార్టెంట్ క్వశ్చన్స్ అంటే ఇవేనా? ఎనీ డౌట్స్? నేను మీకు ఈ లింక్ షేర్ చేస్తాను. ఇది మార్నింగ్ క్లాస్ లింక్. నేను తర్వాత మళ్ళీ ఇది అయిపోయిన తర్వాత ఒక హాఫ్ అన్ అవర్ తర్వాత వస్తుంది. కావాలంటే ఇది కూడా షేర్ చేస్తాను. ఓకే, ఎనీ డౌట్స్? హలో సాజిద్, shall I close?
Sir, 1 minute.
ఓకే, మీ దానిలో నుంచి నాకు రిక్వెస్ట్ పెట్టండి, నేను ఆ రిక్వెస్ట్ చూసి.
సార్ ఒకసారి పిఐడి కంట్రోలర్ చెప్తా ఓవర్ వ్యూ.
పిఐడి దాదాపు రావాలని నేను చూసుకుంటా. సో హియర్ దిస్ ఇస్ ద ప్రపోర్షనల్ కాన్స్టెంట్. కనిపిస్తుంది అది?
Yes, sir.
ప్రపోర్షనల్ కంట్రోలర్, దిస్ ఇస్ నార్మల్ జీ ఆఫ్ ఎస్. ఓకే, సో దీనికి మనం ఏం చేస్తామంటే ప్రపోర్షనల్ కంట్రోలర్ అంటే ఒక కాన్స్టెంట్ గెయిన్ యాడ్ చేస్తాము. ఓకే, సో దీనివల్ల మనకి రూట్ లోకస్ మారుతుంది, బోర్డ్ మారుతుంది. ఓకే, సో విత్ ద ఫ్రీడమ్ టు వేరీ ద గెయిన్ వీఆర్ రెస్ట్రిక్టెడ్ టు మూవ్ ద రూట్ లోకస్. సో గెయిన్ మనం ఎక్స్ట్రా వేరీ చేయలేము, ఎందుకంటే మన సిస్టమ్ అనేది రైట్ హ్యాండ్ సైడ్కి మూవ్ అవుతుంది. ఓకే, సో యువర్ సిగ్నల్, ఎర్రర్ సిగ్నల్ విల్ బి ప్రపోర్షనల్ టు యువర్ కేపీ. ఓకే, సో బోర్డే ప్లాట్ కూడా మారుతుంది. సో హియర్ దిస్ ఇస్ ద సిస్టమ్. So g of s is equal to k by ts plus 1. Okay, then we are adding extra proportional constant. So your system will gain varies. Okay, in that case your steady state will be constant 1 by 1 plus k. It is available. Tarvata integral controller. If you take the integral controller, your output y of is equal to some constant k into integration of your error signal, this one e of s. ఓకే, సో ఈ ఎర్రర్ సిగ్నల్ ఉంటుంది కాబట్టి మనకి will be now integrated. So you are going to eliminate the steady state error. This is the advantage of integral controller. Okay, so with the integral controller, the steady state error is 0. Okay, but the order of the system is increased because integration 1 by s ఉంటుంది కాబట్టి your first order system has become second order system. So you may see that some oscillations in the response. The first order system response will be like this. నార్మల్గా మనకి ఎక్స్పోనెన్షియల్ వేరియేషన్లో ఉంటుంది. ఓకే, సో ఇలా ఉంటుంది. సో బికాస్ ఆఫ్ దిస్ 1 by s, యువర్ second order system and the response will be like this. Okay, but your steady state error has been reduced, but it will make the system to oscillate so that it leads to some instability. This one. Okay, so this is about the integral. So with the disturbances also, it is making the system noise. So here we are going for the PI controller, proportional plus integral controller. Okay, with this also your response steady state error becomes 0 and the stability will be improved. And with the derivative control also, the system has only oscillations. The derivative means k into s. Okay, so here this is a k plus tds. This is a proportional and derivative control. It's going to 1 plus TDS. So it is having some constant K error with the derivative controller. Okay, so it will operates on the derivative term of the change of the error signal. Okay, and the output of the error is proportional to the rate of change of the error signal. Okay, and it takes some corrective action. Okay, and it will improve the system damping. This is our effect of proportional plus derivative controller. Okay, so this is a new transfer function model. Proportional plus derivative plus integral controller. All are acting here, so you can have a stability will be improved and error will be reduced. Okay, so these are the advantages of the system. Stabilized and unstable second order system. Okay, the multiple degrees freedom offered by the PD control can place poles arbitrarily, and the signals, the system has a perfect tracking of step signals because of integral controller. Okay, and the system detects the constant disturbance in it. Okay, so these are the some uh, differences between the proportional PD controller and PA controller. Okay, so this is a mathematical equation. Okay, it will improve the stability, and there is a control over pole locations, perfect tracking of reference inputs, constant disturbance rejection. These are the advantages of PID controllers. Okay, so this is a lag compensation. Okay, so the circuit for lag compensation, which can be derived in the same manner as that of your PID controller. So this will have zeros and poles. In previous case, we had only one pole and one zero. So if you adding a derivative controller, that is a TD of S. So this is a zero. Okay, 1 by S. This is going to be pole. Okay, so this is going to be zero. But with the help of the lag compensation, you can add up one pole and one zero, so that it will compensate the required amount of gain margins and phase margins. So effect of lag lead compensations will be దీంట్లో వేరే ఉంటుంది ఇది మీకు అవసరం లేదు. Okay, so this is what frequency characteristics lead compensation. Okay, so this is 1 plus 1 by t, 1 s plus 1 by alpha. So with this, you're going to get the new transfer function. This is the new transfer function with the lead compensation. So this is a Bode diagram. This is the magnitude plot and the phase plot for this. Okay, so this will have a maximum phase lead here. This is called phi m. Okay, and this can be obtained with the help of your phase angle. Okay, so this is a compensated maximum compensated angle. Okay, and the omega at which your phase angle is here. This particular value can be obtained. Okay, so here this is a phi c at omega maximum. Okay, so this is a formula problem. How can we solve it? Okay, design procedure. Okay, so choice of alpha and t. So the new Bode diagram. మీకు యాక్చువల్గా ఏంటంటే ఫస్ట్ కాంపెన్సేటర్ డిజైన్ చేసిన తర్వాత ఫస్ట్ బ్లాక్ డయాగ్రామ్ బోర్డు డయాగ్రామ్ డ్రా చేయాలి. బోర్డు డయాగ్రామ్ డ్రా చేసిన తర్వాత దాంట్లో నుంచి మనకి గెయిన్ మార్జిన్ ఫేస్ మార్జిన్ కనుక్కోవాలి. కనుక్కున్న తర్వాత కాంపెన్సేటర్ని డిజైన్ చేసి దెన్ అగైన్ యూ హ్యావ్ టు డ్రా ది Bode plot. So you have to verify that you are getting the required phase margin and gain margin or not. Okay, so for that case, we use this design procedure. So this is the designing of a block compensator. Okay, this is the transfer function. Okay, so with the help of this equation, we are going to get the values for im, okay, and omega m. Okay, once you get the phi m and omega m, then you can find out the alpha value. Okay, and t value. Alpha and t finding is important. Once you get alpha and theta, t, then you can substitute into t. Okay, so this is the transfer function for the lead compensator. So this can be included in your system. Okay, this is a normal g of s, and this is your g of j omega. Okay, ఇక్కడ నుంచి మనకి error signal వస్తుంది. This is your compensator and this is your client. So for this plot again, you have to take the closed loop transfer function. Then again you have to draw the Bode plot. Okay, so దానికన్నా ఏంటంటే just you see what is the procedure. Okay, just you learn the procedure how to draw the how to find the alpha and theta from this phi m and omega m. This is important. That's it. Alpha and theta. Just this design procedure you learn. A problem అంతా మనకు అవసరం లేదు. Just you learn up to this particular point, because you know that here the form of phi m is given. Okay, phi m is equal to sin inverse of 1 minus alpha by 1 plus alpha. Okay, so once you get to phi m, you can get the value of alpha, or if alpha is given to you, then you can find phi m. Okay, so this is the way of finding the designing the lead compensator. Similarly, way is for lag compensator and also lag lead compensator. Okay, Sajid. So my computer is maybe switched off.
Yes, sir. Okay, sir. Thank you so much.
Okay, let's start.